This is lesson 1.4. Your objective is that you'll be able to solve absolute value equations. This is the notes for that. You should have already done the warm-up. We'll be moving on. So a couple of vocabulary terms for you. Absolute value equation. An absolute value equation has two solutions. And the distance moves right and left on the number line. So we go to the right and the left. Go to right and left. And we'll see we'll see two versions at least, of how to see that you can also have zero solutions, or really no solutions. And we'll talk about that. And that's actually ties into this next one, extraneous solutions. These are solutions that you might work that wind up not working in the check. So do not work in check. And we need to make sure to check both answers, because it is actually possible to potentially get one where one works and the other one doesn't. We're not going to see any of those anytime soon, but it is possible. Properties of absolute value. A couple things that you need to know about absolute value is if we have the absolute value of A, that's going to equal A. And if I have the absolute value of negative A, that also equals A. We also need to know that you need to work inside absolute value first. And basically we're treating as parentheses. So just a couple things to note as we get started. Let's do a couple examples. Number one says R, the absolute value of R equals 5. And so what we're doing on this is we need to check which one goes, or what we kind of get from this. And the way that I kind of approach it is I look at this and I say, what do I want on the inside of this? Not necessarily for R, but just in general. What number would I want inside this parentheses to make this? To make the 5. So what number would I want inside of this parentheses to make 5? And the answer is positive 5 and negative 5. A lot of times people like to kind of identify this if they're thinking on a number line. If they're on a number line, and if you're starting at 0, you're going to the left, you're going to negative 5, and to the right, you're going to positive 5. And so you can kind of down here, like, okay, if I'm going to the right, R needs to equal 5, and if I'm going to the left, R equals negative 5. Now what we need to do is we need to make sure that we check these. We want to check and make sure there's none of those extraneous solutions, and so we plug these in. So I do the absolute value of R equals 5, and the absolute value of R equals 5. And so instead of R, I'm going to put in 5. Instead of R, I'm going to put in negative 5, the other answer that I got. And so I get 5 equals 5. And 5 equals 5, and that checks out. Okay. All right, let's go to number 2. Number 2 says this: the absolute value of Q equals negative 7. Now, whenever we're talking about this, and we kind of talked about this at the beginning, that an absolute value means the distance from 0. And kind of something that maybe you know, maybe you don't know, but you actually can't go a negative distance. Even if you go, like if you walk backwards, you're still going a positive distance. So whenever we see a negative on this right-hand side, I like to kind of say, hey, you should start getting some like alarm bells going off saying, hey, whoa, something's up here. Because in this case, there is no solution. Again, distance cannot be negative. Okay. All right, so now we get to skip to number 3. That's kind of the nice thing about finding some of those. Now we go to it's number 3, which says the absolute value of b minus 2, close that, equals 5. And in looking at this, I kind of go through two types of checks as I'm going. The first check that needs to match off, so I say, okay, or the first kind of box that I will is it isolated? And when I say is it isolated, I mean, is there anything outside of the absolute value side on the same side as the absolute value? In this case, there isn't. The next thing I ask is the number that I'm equaling positive or 0? And in this case, it's yes. If both of those are s, we need to do what we call a split. So in a split, and some people like to draw this, some people like to say that L and that R, we say b minus 2 equals 5. That one's kind of easy to see. And then we say b minus 2 equals negative 5. And a lot of people go, well, wait, where'd you just come up with this negative? Remember, I wanted what on the inside of this absolute value, ignoring the b minus 2, would make 5. And the answers are 5 and negative 5. And this is a minus sign, not a equals. So when I do this, I now get to solve this. And the kind of the cool thing, the way that this is set up, is you get to basically do just kind of one step, and you can do it across all of them. That said, if you want to do just one, that's totally fine. So I'm going to add 2 to both sides. And so I get b equals 7, and I get b equals negative 3. So now if I do my check, I get, I go absolute value b minus 2, absolute value equals 5, and then write it again, because we're checking two answers. Instead of b, I'm going to write 7. Instead of b, I'm going to write negative 3. And I'm going to solve. And so I go 7 minus 2 is 5, which equals 5. And the absolute value of negative 5 needs to equal 5. And so I get 5 equals 5. That checks off. And I get 5 equals 5. And that checks off. Okay, let's go to number 4. Number 4 says absolute value of a over 3 equals 4. So again, in solving this, I first start off, I say, is it isolated in this case? Yes, it's isolated. What I mean by isolated? There's nothing around the absolute value sign that's not inside of it. The next thing I ask is the number that we're equaling, is it a positive or a 0? And the answer to that is yes. So what that means is we need to do this split. So I get a over 3 equals 4, and a over 3 equals negative 4. And some of you might be catching on to the idea that it's just the positive and the negative of this outside number. And that's true as long as you can match off, or you can check off that it's isolated before you do that. So in doing this, I want to get rid of a over 3. I want to get rid of the 3. So in order to undo division, the inverse operation is multiplication. So I multiply by 3. I'm going to do that to everything. So I get a equals 12. And I get a equals negative 12. Again, do my check. And so I do absolute value of a over 3, absolute value, equals 4. And the absolute value of a over 3 equals 4. And instead of a, I'm going to put in 12. And instead of a, I'm going to put in negative 12. So I get the absolute value of 4, the absolute value of negative 4, so 4 equals 4, and 4 equals 4. Okay, number 5. A little bit more complex. I have 8y minus 3, absolute value, equals 13. First thing I check, I look at it and I say, okay, is the absolute value by itself? Yes, it is. Is the number that I'm equaling positive or 0? And the answer is yes, it is. Now that means I can do my split. So I get 8y minus 3 equals 13, and I get 8y minus 3 equals negative 13. So what do? I add 3 to all parts. So what I get is 8y equals 16, and 8y equals negative 10. Next step, divide by 8. So I get y equals 2, and y equals negative 10 over 8. If you want to rewrite this, you don't necessarily need to, you should for writing down the answer. However, solving, it actually makes more sense to leave it like this, we'll see that here in a second, is negative 5 over 4. If they require you to change it into a decimal, you can, and this winds up being negative 1.25. I personally like to avoid decimals as much as possible. Now we need to do our check. So I do the absolute value of 8y minus 3 equals 13. Absolute value of 8y minus 3 equals 13. Instead of y, I'm going to write in 2. Instead of y, I'm going to write in negative, I'm actually going to do negative 10 over 8.